Hello, I'm going to work through a worked example for calculating forces on charges using Coulomb's law. So this will answer a couple of questions that came up in the class for like tutorials, another example, and maybe something slightly harder. Something involves different charges so we can know which kind of charges we're using for calculations. So the question is, there's a 2 microcoulomb charge in between a 1 microcoulomb charge and a negative 3 microcoulomb charge. And I'm looking for the net force acting on this charge here. So the first thing I would do is I'd kind of get in my head, kind of square my head, what kind of forces are acting on that. We could even do a force diagram, actually, on that thing. Like, if that's the charge. The 1 microcoulomb charge, since they're the same, they're both positives, that means they're going to repel. So what I would say is there's this force here, which I'd call F. And I go 1 on 2. So this is the force of 1 acting on 2. And then there's another force between these two charges. And if this one's negative, it's going to attract the 2 microcoulomb charge. So this is actually also going to be in the same direction. So that's going to be force, and this is, I'm going to call it 3 on 2. And I think if you write the subscripts like that, that would really help for you to be clarifying what force is acting on what and in what direction they are. So you'll notice it's on 2, because I'm looking for the forces acting on charge 2. Okay, so at this point, we'll calculate these two forces, and then we'll add. This is going to be a pretty easy one because we just add them together. There's no complicated vector stuff going on. They're vectors. It's just they're simple vectors. So I'd go. I'll do this one first. F3 on 2. So this is K, and I'm going to call this one Q3, Q2, divide by R squared. So this is 9e to the 9. Q3, so that's 3 times 10 to the negative 6. And 2 is 2 times 10 to the negative 6. I don't put a negative sign in there. The negative sign tells us the direction. It's not like it's a positive or negative number. It's actually just telling us direction. And the direction is taken care of. I know it's going to the right. And then the distance is, so if this is 35 from there to there, that's 85. That means this must be, better get this right. I believe that's 50 centimeters. Yeah. So I have to convert that to meters, and I'm going to square it. And that will give me the force. I'm going to show you on my calculator something that everybody should be doing, but it totally depends on your kind of calculator you have. But you should be using a key that's like E or EE or 10 to the X. Actually, let me show you some different calculators you guys probably have and what keys you're going to want to use. So here's 3 popular calculators. So if you have a Texas Instrument that looks kind of like this guy here, if you wanted to do, like, the value of K is 9 times 10 to the power 9. If you want to use K in this calculator, what you'd press is you'd press the 9 button, then you'd press second key, so that's this one here. Then you'd press this key here to get the E, and then you would press 9. So that's how you punch in 9 times 10 to the power 9 on the Texas Instrument. The Casio, it's similar. You'd go, it's a bit easier on the Casio actually. You go 9, and then you press the key that's down here. It's 10 times 10 to the power x, this guy, and then you press 9. The Texas Instrument TI, it's the same for this one. It's this EE key. So that's how you punch in. That's for sure how you should be doing scientific notation in your calculator. And the reason why is it helps out, especially when you're using like square and square roots. So for instance, it's important, like let's suppose you had to go f is equal to k 2 times 3 divided by, and let's suppose this is a really big number in the bottom for whatever reason. It's 6.2 times 10 to the negative 6, and it's all squared. You can do this okay in your calculator if you use brackets. You could actually go bracket 6 dot 2 and then press the multiplication key, and then you could do like, what's that key, like x to the y and 10, I don't know, like you could do a bunch of things like that, then do that end bracket, then you could do power to this, you could square it, you could do all that. But by far and away the easiest way and most reliable way, and the way that's less prone to mistakes, is if you'd go 6.2 and then like 10 to the x 10x negative 6, and then you could square it. You don't have to worry about brackets. So if you use this key, as soon as you use this key, it treats this all as one number, and you don't have to do any brackets with it. Same with like if you're dividing. If you wanted like to divide this, like if you're doing k times 2 times 3 divide by this, you can put this all in and you don't have to use any brackets. Anyways, back to the problem. So where was I? Oh yeah, punching this stuff into the calculator. So my calculator, on my calculator, it's this E key. Okay, so 9e to, oops, 99, 3e to the negative 6 times 2e to the negative 6 times 0.5 squared divide. So I get, what was it? 0.216. 0.216 newtons right. Okay, now I'm going to do the force of 1 acting on 2. So 1 on 2 is equal to k. So that's 1 times 10 to the negative 6, 2 times 10 to the negative 6, divided by 0.35 squared. Uh, 0.35. 0.147. That's to the right. So then the final net force is when we add those together. So I just add them together and I get 0.363. That's it. Yeah, I don't think there's anything else to say about this problem. Oh, the other thing is, once you get used to these numbers, if you're good with numbers, like working with exponents in your head, you'll know right away. You don't have to keep punching in 10 to the negative 6, 10 to the negative 6. You could just punch this in as, so I'm gonna recalculate this one, which is maybe slightly faster, but you don't only do this if you're really comfortable for numbers. The exponents are, let me rewrite this actually. It should be rewritten as 9 times 10 to the power of 9. Okay, that's a 9, this is negative 6. So you add those together, you get 3. 3 minus 6. So this whole thing is to the power of negative 3. So I could calculate it like this. I could go 9 e to the negative 3, and then times it by 3, times it by 2, divide by 0.5 squared. Oops, I must have done something wrong. 9e to the negative 3, 3 times 2 times 0.5 squared. So same number. So in fact, some students can go through this whole unit without even using a scientific calculator. They just do the exponents in their head, and then they do calculate the rest of the stuff like they normally would. So they go 9 times 3 times 2 divided by 0.5 squared, and then they go times 10 to the negative 3. Okay. That's it for this question.